want to look at interpreting oscilloscope display. Now, I copied this image from a website called practicabledesigns.com. They talk about this sort of thing here. Now, just a reminder of certain things. Remember, we're looking at a sine wave, all right? And we have the cycles here. Remember, a cycle is a set of changes that takes place, it's completed, and then it's about to repeat itself. So a cycle, for example, going from 0 up. Let me just draw the horizontal axis. Say this is our horizontal axis. Going from 0 up, it starts here, and the next time it happens again is here. So from here to here is a cycle. Okay, you go from 0 to maximum, down to 0, then 0 to maximum negative, down up to 0. You're going from 0 to maximum positive again here. This was from 0 to maximum positive, you're going from 0 to maximum positive again here. So you complete one cycle here. Right? The frequency is how many of these cycles are completed in 1 second. Remember that. Now, suppose you looking at the oscilloscope and you set it at, say, 0.5 volts per division, right? Volts per division. And if I should just type it instead of trying to write it. 0.5 volts per division. All right. Oh, that's the vertical. The vertical scale is 0.5 volts per division. How many volts is this oscilloscope measuring? You can estimate the voltage from the oscilloscope. And notice I say not measuring or estimate, because it's just an estimate. It's a graph. It's not that accurate. You can see the divisions here. What they mean by division are these boxes. The height from here to here is a division. The height from of this box is another division. You can see all these square boxes, right? So this goes up to 1, 2, almost 2 divisions. Let's say it's 1.9 divisions. So the voltage level would be V equal, remember, it says 0.5 volt per division. You go up 1 division, that's 0.5 volts. If it went up 2 divisions, that would be another 0.5 volts, which is 1 volt. Alright? So in this case, you would multiply 0.5 by 2 to get the 1. In this case, you're going to have 0.5 volts per division multiplied by 0.9 division. Division will cancel division. The units will cancel out. But 0.5, oh, it's not 0.9, it's 1.9. My. I forgot that we had passed a whole division already. So we have to go up to the top here. We have to go from 0, 1 division, and then go up again. It doesn't really touch 2. So I estimate it's about 0.9. So it's 0.5 by 1.9. How much is that? 5 nines. Oh, 0.5 by 1.9. 1.9, 0.5. Let's say 5 times 1.9 and then divide it by 10. 5 9 45, you know, the 5 carry 1, carry 4. 5 1 5 6 7 8 9. So in that case, that would be 9.5 and then we divide again because it was originally 0.5, not 5. So it would be 0.95. So we have 0.95 volts, right? That's the vertical division. Let's make some changes to this and see what would happen if we imagine that it was another setting. Suppose it was 0.1 volts per division. What would be the voltage? Estimate the voltage that's being measured, right? Here, what you'd have to do is say you have one close to 2 divisions, almost 2 divisions. Say you have 1.9 divisions. If you go up 0.1 volt per division, you go up 1 division, that's 0.1 volt. You go up 2 divisions, that would be another 0.1, which is 0.2 volts. This wave doesn't seem as if it touched 2. So let's say it's again 0.9 division. So you go 1.9 divisions. So the voltage is the 0.1 volts per division multiplied by how many divisions? 1.9 divisions. Division cancel division. So what you have is 0.1 by 1.9, which is 0.19 volts. You see that? So what you have there is 0.19 volts. Let's do one more. Suppose what you had was not 0.1 volt per division. Suppose you have 1 point. Suppose you had 2 volts per divisions. You have 2 volts per division. The question is, what would be the voltage that you're looking at on the oscilloscope? Let me redraw this line. I erase part of the line. This is my vertical line. Alright? So the voltage you would measure is 2 volts per division multiplied by how many divisions? 1.9 divisions. So 2 by 1.9 would be 3.629, no, 3.8, not 6. 2 9s 18, bring down the 8. Carry 1, 2, 1, 2, 1, 3. 3.8 volts, alright? So that's what you have. Now the thing is, remember, if the wave was something like this, then you would be looking at going 1 division, 2 divisions, 3, just above 3 divisions, 3 point something divisions. So you'd have to multiply 2 volt by 3. Alright? It will be 6 volts, a little over 6 volts, depending on your estimate. If the wave was like this, and you estimate that the wave went up halfway the height of one of these square boxes. Remember, we have the square boxes here. Then, oh, well, it's really a square. Let me redraw it. These are the square boxes. Just in case you can't see it very well, it's kind of faint. Alright. So, this one, right here, the waves seem to go about halfway up. So it will be 0.5 divisions. So what you'll have is 2 volts per division times 0.5, which is 1 volt. Alright. Now, in our next video, we want to look at the horizontal scale. So I'll see you then.